Topic 3.3 Standard Test Methods and Interpretation. This slide from now on, I will give you the example of the calculation of test parameters. Here we have 4 questions. According to the test data provided over here on your left-hand side, please determine A. Young's modulus, B. yield strength at 0.2% strain, C. Maximum load for a cylindrical rod specimen having the diameter of 12.8 millimeters, and D. The change in length or delta L of a specimen having L0 or the original gate length of 250 millimeter that is subject to a tensile stress of 345 megapascal. So let's start at the first one. If you want to find out the Young's modulus, so you have to look for the properties within the linear portion of the stress-strain curve to find the slope. And over here is the enlarged picture of the stress-strain curve in the linear portion. I've given you the slope of this curve as the red line here. And from the definition of Young's modulus, we have to find stress and strain in the linear portion. Then over here, I'm crossing the green line to give stress at 150. And down here, I'm drawing the line crossing the strain at 0.0016. As you can see from here, this scale showing 0.005. And this point is for the strain at 0.002. And therefore, the green line is crossing the x-axis at around 0.0016. So from the definition of the Young modulus is delta stress over delta strain. Then we have 100 minus 0 over 0.0016 minus 0 megapascal. And we come out with the number 93,750 megapascal. That's a huge number, so we have to change the unit a little bit from megapascal to gigapascal. And normally Young modulus has a unit in gigapascal. So now we have 93.8 gigapascal as the answer. Next is the yield strength at 0.2% strain. As I said before, 0.2% of strain means the strain at 0.002. So from the dashed line parallel to the slope of the stress-strain curve, we now arrived at the values of 0.002 here. And therefore, the yield strength at 0.2% strain can be found when you draw the green line across the y-axis. Now we obtain the value of 250 megapascal. And that is the answer. Easy, isn't it? Question C. You have to find the maximum load for a cylindrical rod specimen having the diameter of 12.8 millimeters. So thinking about the relationship that we have to use maximum load, and that is the maximum tensile strength. So from the stress-strain curve given here, the maximum tensile strength is the values that you draw the green line across the y-axis here. Now we come out with the number 450 megapascal. And from this, we can find out the maximum load, providing that we can calculate the original areas of the specimen from the given diameter of the specimens. From maximum tensile strength equals P max over A naught. If you want to find P max, we then have S max times A naught. Then you put in numbers in there. P max equals 450 times 10 to the 6 Pascal. And don't forget to change megapascal into 10 to the 6 because you need to change the unit of Pascal to Newton over meter square. And the whole phrase here is for original area of the specimen, which are pi r squared in the unit of meter square. Then over here we have 12.8 times 10 to the minus 3 over 2. And therefore, we have P max equals 57,900 Newton or 58 kilonewtons. Remember, check again before you go answer it that the load is normally in Newton. And for the large amount, you can change the unit to kilonewtons. That is the normal case. And last question is for you to find the change in length or delta L of a specimen with the original gauge length of 250 millimeter. That is subject to a tensile stress of 345 megapascal. You can think about the relationship of strain that is equal to delta L over L. And from the stress-strain relationship, you can find the strain as a result of the applied tensile stress of 345. Here we go. at the stress level of 345 here from the green line, crossing the stress strain curve, leading to the dashed green line down here, crossing the strain. And we come out with the strain at 0.06. And from the relationship of strain equals delta L over L naught, we can then calculate the delta L, which is the strain times L naught. That is equal to 0.06 times 250 millimeter. And so finally, we arrive at the delta L values of 15 millimeter. That's the answer. So, from this example, I think you get some ideas about the calculation of the test parameters, and you can practice more on your homework.